In this video we're going to look at a couple of properties of triangles which will be useful to us throughout the rest of the course. First of all, we're going to look at an equation which will give us the area of a triangle, and secondly we're going to look at the three angles of a triangle adding up to 180 degrees. So we're going to start off by looking at the area of a triangle. But let's look first of all at the area of a rectangle. So we have a rectangle drawn here. Now the rectangle can be said to have a length and a breadth, but rather than using the terms length and breadth, we're going to use the term base, because this is the base of the rectangle, and we're going to use the height. So we can say that we have a base here and we have a height. Now the area of this rectangle is going to be base times height. That's how we define the area of this shape. Now if we wanted to generate a triangle from this, we could draw a line from this point here to this point here, and that will give us two triangles. Now we can note that the area of this triangle here is exactly the same as the area of this triangle here. And you can convince yourself of that by looking at the lengths. This length here is the same as this length here. This length is the same as this length. And finally the diagonal lengths are the same. And you can see that the angles are the same as well. In fact, if we take this triangle here and we rotate it round 180 degrees clockwise, you can see that this point here will rotate round to this point, and this point here will rotate round to this point, and this point will rotate round to the its requisite point as well. So all of the angles are the same, all of the lengths are the same. So this triangle is exactly the same as this triangle here. So the areas are exactly the same. So that means that if the area of this rectangle is base times height, then the area of one of those triangles is just going to be half of the full area. So we can say right away that the area of a triangle is a half base times height. And this is the little equation that we're going to use for the area of a triangle. Now this doesn't constitute a mathematical proof, but we're not interested in the proof for the moment. We just want to get to the equation so that we can use it throughout the rest of the course. Now this equation is going to work for all triangles. So let's say for instance we were to take the triangle here and we change the shape of it. So we've got a shape that looks something like this here. Now from this triangle here we can generate another shape which we call a parallelogram. So there is a parallelogram there. So in a parallelogram we're going to have this length here is the same as this length here, and this length here is the same as this length here. And in fact this triangle here is the same area as this triangle here. But in a parallelogram, the area of a parallelogram is the base, which is this length, times the height, which is the height from the bottom to the top. So that's the area of the entire parallelogram. But we're only wanting half of the parallelogram area. So the half of the parallelogram area, again, is going to just be the half of the base times the height. So we get it back to exactly the same equation. A half base times height. And we can actually see that here, that the area of a parallelogram is just the base times the height. Because from every parallelogram we can just generate another rectangle, which is exactly the same area. So in this instance here we could take this little triangle here and we could place it up here. and we would be back to exactly the same rectangle. So the area of this rectangle here is exactly the same as the area of the parallelogram. So irrespective of what triangle we generate, the area is always going to be given by a half base times height. So now let's go ahead and we'll look at the angles adding up to 180 degrees. Now let's look at the sum of the three angles of a triangle. So let's take some random triangle here, and we're going to have three angles. Let's call them theta 1, theta 2 and theta 3. And the question is, when we add these three angles up in degrees, what number do we get? Well, let's imagine that we drew a line which is parallel to this line here. So that's a new line here, and it's parallel to this line. Then we can say here that if we were to start at this point here and work our way all the way round until we got back to that point, then we would have gone round 360 degrees. But let's say we started at this point and we only went round to here, then we would have gone round 180 degrees. So it means that this angle here, plus this angle here, plus this angle here is 180 degrees. But what is this angle and this angle? Well, this angle here is nothing other than theta 1, and this angle here is theta 3. So why is this angle theta 1 and this angle theta 3? Well, let's imagine we were to draw a little rectangle. Then we can see here that this right angle here is the same as this right angle here. And in fact, if we drew a little point here and we rotated this rectangle round about in either a clockwise or an anti-clockwise direction, it wouldn't matter, and we rotated it round 180 degrees, then this angle here would rotate all the way round to this angle here. The right angle would rotate round to this angle here, and the angle here would rotate round to this angle here. So we would have rotated this round 180 degrees, and this angle would have rotated round to here. So this here must just be the angle theta 1. And you can see this as well if we draw out a Z, then the angle here would be the same as the angle here. Now, via the same result, if we draw out this Z here, you can see that this angle theta 3 is the same as this angle in here. So this means that the angles theta 1 plus theta 2 plus theta 3 adds up to 180 degrees. So that means that the sum of the angles in the triangle, which is just theta 1, theta 2 and theta 3, must also add up to 180 degrees. So we could write the sum of the three angles of a triangle add up to 180 degrees. So that covers everything we need to know about the basic properties of triangles, which we will need throughout the rest of this course.